Coefficient of linear expansion of brass and steel rods are alpha 1 and alpha 2. Lengths of brass and steel rods are L1 and L2 respectively. If L2 minus L1 is maintained same at all temperatures, this is the key. L2 minus L1 is maintained the same across all temperatures. Which of the following relations hold good? Okay, so here is something simple. Let's say this is brass and the length of that is L2. And let's say this is steel and length of that is L1. Okay, now when you heat L2 or the brass thing, it certainly will expand, and let's say it expands by delta L2. And same thing, if you heat by the same temperature difference, it might expand by delta L1. Correct? Now, what is delta L2 or delta L1 dependent upon? It is dependent upon the coefficient of expansion for brass, which is alpha 1, and same thing alpha 2. Not only on that, it also depends on how much of this rod has been heated. If you heat part of this rod, then it might expand less. If you heat full of this rod, then it might expand more. So it also depends on how much or which part or what part of brass you have, that is, this is brass, what part of the rod you have heated. And the same thing applies here too. So if you heat only some part of our steel, then it might expand only by this much. If you heat the entire steel, that might expand by this much. The key here is we have to ensure that he has told us L2 minus L1 is always constant, which means we have to ensure that the expansion that happens in the first rod and the expansion that happens in the second rod is always the same, which is this expansion is always the same. We need to ensure that is delta L2 is always equals to delta L1. Okay, now we know that we need to maintain this constant. Let's find out what is the equation for expansion, or what is coefficient of expansion. The formula for that is alpha 1 is 1 by L1 delta L1 delta T. T is the change in temperature. Delta L1 is the change in length. This is equation 2, and equation 3 alpha 2 is nothing but 1 by L2 delta L2 divided by delta T. This is equation 3. Let's switch this around and find out. We know that delta T is constant, right? We are heating both the rods the same amount of time, or the same temperature difference we are maintaining, which means these delta T's are equal. So let's bring those delta T's on this side. Delta T is nothing but L1 by L1 delta L1 divided by alpha 1, and which is similarly delta T is 1 by L2 alpha, that is delta L2 divided by alpha 2. So these are same, so we can equate these two. When we equate that, it becomes 1 by L1 delta L1 alpha 1 equal to 1 by L2 delta L2 alpha 2, right? This is our equation number 4. Now if you look this carefully, here is equation 1, delta L2 equals to delta L2. So we can cancel these two out, right? When we cancel, these divide out each other. So finally what is left is alpha 1 L1, right? Or you can move this way now. Bring this side and bring this side. So mathematical transformation, L2 alpha 2 is nothing but L1 alpha 1, and that is the right answer. The right answer is answer number 4, which is L1 alpha 1 equal to L2 alpha 2. Thank you.